Hi, I am Shantanu from IIT Bhopal. So, I am going to talk about this course, that is Microscale Sensors or MEMS. So, welcome to the first module of this course. Before we go to actually the details of MEMS, what we need to understand that why this is important, why MEMS are important, right? So, the first thing is you see that micro or nanoscale systems are at the heart of modern day technology. You take like a laptop or a mobile phone, there are billions of transistors and other components, right, which are kind of very much necessary for that for the working of that particular device. Now, all these microelectronic circuits or all these elements are actually product of this technology. Okay. Next is like microelectromechanical systems, which is topic of this course, and microelectronic circuits, which you are I guess many of you are already familiar with it, are like uses the similar kind of process technology. What does it mean? Means that the way this kind of sensors are made, same way the microelectronic circuits are also made, like the similar way. Actually, microelectronic circuit process technology started from like several decades back, right? And MEMS or this sensors technology actually followed that technique. Now, the idea or the objective of this course is to get familiar with these kind of sensors, like how do they work, how are they made, etc. And most importantly, that processes by which you can make this kind of devices, right? And you see that one thing is that knowing this kind of sensors, having an idea of getting familiarized with this kind of sensors. Another thing is like the most important thing is that like if you need to use or if you need any of this kind of microscale sensors for your research or project, then how are you going to design it, how are you going to make it. So that will be taught in this course. So what will you learn? The first point is application, like why these sensors are important, where you can apply this knowledge. Second is working principle, like how do they work actually. And third is fabrication, or the most important part, that is how are they made. Like you see, these are very small sensors, right? I am talking about micron or even smaller scale. So how you can make a device in that scale. And as I was saying, that directly for your research, which is what is important is how to design and make microscale devices for your research or project work. Now, the brief outline of the course. So the first week, as it is a 4-week course, then the first week we will discuss about like introduction and basic concepts. So you will have an idea about what are microsensors and why are they important. Then how do they work, like working principles, and how in MEMS, as we are talking about microelectromechanical systems, how the different mechanical and electronic elements work together. So that we will study. And next is the most important part, how are they made, like microfabrication or lithography. These are the usual techniques we use for making these kind of devices. And finally, practical example. So case studies will be discussed with specific examples of MEMS pressure sensor and accelerometer, and we will use this knowledge to make these two devices. The next question, why we are talking about at all about this microscale sensors? Why we need to go such small scale? We know that the pressure sensors or temperature sensors, whatever sensors we are going to discuss in this course, are already existing. So let me give you this example. That is, let's say this patient had a bike accident, and because of this some internal hemorrhage has happened inside his brain. Now doctors, before operating, they need to know that how much is the fluid accumulation inside his brain, and for that they need to measure the pressure of the cerebrospinal fluid or blood inside his brain. Now for that what we need? We need a pressure gauge. And if you see, these are the usual pressure gauges available in market. These are pretty big in size, right? And you cannot open a human skull and then just put this gauge inside the human skull. even the probes for these kind of pressure gauges are also very big, so it cannot be put inside a human brain. What is the solution? Solution is MEMS pressure sensor, and MEMS pressure sensors can be this kind of small sensors which can be put on tip of a needle. Okay, so on tip of a needle you can put these sensors and then can drill a small hole inside the human skull and then can put the probe through that hole. Okay, and then the doctor will know from outside that how much is the pressure reading or how much fluid has built up inside the brain. And in this course we are all going to talk about this kind of sensors which can be used in such a situation where the normal or the conventional sensors or gauges cannot be used. So before going into the details, let me just show you one glimpse of one of the MEMS pressure sensors made in India. So this is Professor K.N. Bhatt, made in IIT Madras. This MEMS pressure sensor totally made in India and with using Indian technology. And this kind of sensors you can actually use for measuring, like as I was saying, that blood pressure or intracranial pressure. Then let's say even on aviation technology, for light combat aircraft we need to measure pressure at different points of the wing, and you cannot put a big pressure sensor on top of a aircraft, because then the plane will not fly at all, right? So in those cases this kind of MEMS pressure sensors are used, though packaged in different way, but ultimately the sensor or the main chip is same. So now as we are talking about small, let's give you some idea about what we mean by small, how small actually we are talking about, right? So you know about atoms and all. Atoms are in angstrom range, okay? So one atom, like hydrogen atom, is about 0.5 angstrom or in that scale. Then you have molecules or DNA in nanometer scale, then nanostructures or viruses in like few tens of nanometer scale. Then the smallest microelectronic structure is about let's say just about 1 micron or little lesser. Then you have bacteria, biological cells, MEMS devices and all are in that microscale, right? So and one human's hair diameter is about 100 micron or little more. So MEMS devices operate in this range. Then you have packaged ICs or packaged MEMS sensors or lab on a chip, and finally in the macro scale you have like plain old mechanics or human, animal, plants, whatever we see on our everyday basis and on our surrounding, everything is in macro scale. So in this course we are going to talk about this region, that is micro scale region where the MEMS devices operate. So we are talking many times about MEMS. What is MEMS? Full form MEMS is micro electromechanical systems. Now MEMS or micro electromechanical system is more popular in like India or US, whereas microsystem technology is mostly used in Europe. Then micro machines used in Japan, or microscience by some people around the world, like that. So it has different names in different countries, but ultimately this all points to the systems or devices which are in microscale and which operate in microscale range. And if you go to even below 1 micron, which geometries or which feature size can be measured in nanometer scale, then it is NEMS or nano electromechanical systems. For the part of this course we will be only restricted to micro electromechanical systems. Now we know different nomenclature of MEMS, so let's talk about in little bit more detail about MEMS. So as I am telling that micro electromechanical systems, right? But currently MEMS devices are possible even without electrical or mechanically moving parts. For example, static microfluidic structures. So we will go or discuss about these things while we move on in this course, right? But along with the electric and mechanical part, even the thermal, fluidic and other domains are also very much important in this course. And you will see many examples of electrothermal and fluidic actuations or micro bubble pump, etc. in this course. Another important point is that the MEMS need not to be a sensor. Okay, it can be an actuator also, like switch or amplifier, etc. So we will discuss this as we move along. To give you some examples of MEMS devices, right? The first example is like this projector mirror. So these are tiltable mirrors which tilting angle you can control using electrical signals or pulses. Okay, and in this case, this tilting angle will decide that where the pixel will form and what will be the intensity and color of the pixel, etc. So there are like thousands of these micro mirrors which are working inside a projector to make the picture projected on your screen. Then an inkjet printer. What is an inkjet printer? So as you can see, so there is an orifice through or hole, and then you have your ink which is surrounding a bubble. Then you have a resistive heater. So as you pass some current, it heats up and the bubble or the air bubble bursts, and that shoots out the ink on the paper. So this is how inkjet printer head works. This is also product of micro technology or micro electromechanical system. Another example is like MEMS heater. So as I was saying, that is not only a sensor, it is an actuator also, right? For that purpose, I can give this example where you can make these microscale coils at specific space on your silicon wafer, and then you can heat up only at that particular region, and so you can microscopically control the temperature at different regions of your sample. And few more examples of MEMS, like where it is useful. For biological devices, MEMS is nowadays very much important for making micro needles, etc., which are very much important for separating cells or in injecting some fluid from one system to another system. This kind of micro needles can be made using MEMS technology. Then microfluidic devices, which are also very much important in biological system, like for experimenting with biological system, there also you need microsystem or this kind of technology. Then another very important example of MEMS is motion sensors. So you see your mobile have all this, you play these games like motion games, right? And there you have your different sensors which are called like accelerometer for measuring acceleration, or gyroscopes for measuring rotation. And these kind of sensors are actually in micron scale range, and this is product of this microsystem technology which we are going to discuss in this course. Then you have like chemistry based MEMS sensors, like gas sensors, where actually if some material is exposed to some kind of gases, then what happens is there are some conductivity, electrical properties like conductivity or resistivity, etc. It changes, and by measuring that electrical voltage output, you can measure that how much is the presence of that gas, or what is the concentration of that particular gas in the ambient. So there also you can use this kind of micro electromechanical systems. Next is very important example, that is force sensors. In case of force sensors, you have a material which if it is exposed to stress or strain, then its electrical properties changes. Like if you bend it, then it's under tension and it becomes little bit elongated, and because of that its resistivity changes, like for piezoresistive materials. And in those cases, by measuring how much is the change in resistance, you can measure that how much is the deflection caused, and from that deflection you can measure that how much is the force has been applied for making that deflection. So this kind of force sensors are also made using microfabrication technologies. Finally, I will end this module with this slide, that is general working principle for MEMS sensor. you take any MEMS sensor, it can work following this general principle. So there is some external force which is applying on some moving structure. So let's assume this is a this is like a cantilever which is fixed as this at this end and free at this end, right? Now if I apply an external force, then it bends like this. Once it bends, then if I put some piezoresistive material, as I was talking in the last slide, piezoresistive material which changes its resistivity because of stress or strain, then its resistance changes, and once this moving structure is deflected, the resistance or that electrical property is changed, and by measuring that electrical property we can calculate that how much is the deflection and how much is the force I am applying to make this deflection. Rather than electrical properties, it can be also, the deflection can be also measured using optical technique also. Like let's say if you have focused a laser on this end of the cantilever, then as it deflects, then the reflected beam also shifts, and from that shift using a photodetector we can measure that how much is the deflection of the cantilever tip, and accordingly we can measure that how much is the force applied on this particular structure. So any MEMS sensor you take, or in general any MEMS sensor you take, there is an external force which is acting on some kind of moving structure like cantilever or membrane, and that structure is because of that force, that structure is deflected, and then that deflection causes some kind of electrical change or optical change, through which we can measure that particular deflection and can back calculate the applied external force. So this is the end of this module.